All right, if you're managing IT in a place that has, let's say, some real-world constraints, buzzing factory floors, ancient equipment that just won't die, and budgets that are always tight, then you're in the right place. We're going to walk through the whole story of network security, from the old school way of building walls to the brand new idea of trusting absolutely nothing. So let's get right into it. I want you to picture an old school factory. You know the kind. It's just one gigantic, wide open room. You've got CNC machines over here, office computers over there, and maybe a guest Wi-Fi access point in the corner. Everything and everyone is in the same open space. Well, that's exactly what a flat network is. Once somebody's inside that front door, they can basically wander over to any machine they want. It's simple for sure, but you can probably see where this is going. It's not very secure. So what's the first logical step to make things more secure? Well, you build some walls, right? You create some separation to control who can go where. And in the world of networking, our walls have a special name. They're called VLANs. So a VLAN, or a virtual local area network, is a pretty clever trick. It lets you take one single physical network and digitally slice it up into multiple, totally separate networks. It's just like building actual walls inside our factory. Suddenly, you've got a specific zone just for operations, a separate one for the office staff, and another one way over there for the guest network. The key thing is, they're all still running on the exact same physical switches and cables, but logically, they're worlds apart. And the difference here is, well, it's night and day. Over on the left, in our open factory, if one machine gets infected with something nasty, that attacker can see and try to talk to every other machine on the floor. But on the right, with our new walls up, a breach is contained. If someone's laptop on the guest network gets compromised, that attack can't just jump over the wall into the critical operations network. It basically stops certain kinds of attacks dead in their tracks. The walls are working. But, and there's always a but, right? In today's really complex world, those simple walls are starting to show some serious cracks. Let's dig into why this traditional model is starting to hit its limits. And this quote right here, it gets to the absolute heart of the problem. See, the whole walled factory idea is built on one huge assumption, that once you're inside a room, you're a good guy. You can be trusted. But what happens if the threat is already inside? A compromised laptop, an employee who accidentally clicks the wrong link. That's where this whole model really starts to fall apart. The truth is, our factory walls are becoming, well, they're porous. They're full of holes. Just think about it for a second. You've got remote engineers who need access to one specific machine, not the entire operations floor. You're using cloud services that live completely outside your factory walls. And of course, the big one, that 20-year-old piece of operational tech that runs your most important process. You can't patch it, you can't update it, but it has to be on the network. The clean, simple boundaries we used to have, they're pretty much gone. So this is where we need a totally new way of thinking about security. Instead of just relying on bigger, better walls, we're going to introduce a new character into our factory, a super vigilant, slightly paranoid security guard. And this is the core idea behind Zero Trust. So the main idea, and this is the official definition from NIST, that's the National Institute of Standards and Technology, is actually pretty simple when you boil it down. We're getting rid of the old motto of trust but verify. The new motto is never trust, always verify. It doesn't matter if you're inside the building or outside. It doesn't matter who you are. Every single request to access anything has to be proven as legitimate, every single time. Let's go back to our factory. I want you to forget the walls exist for just a moment. Instead, imagine there is a dedicated security guard standing right next to every single machine. Before anyone, an employee, another machine, anyone, can touch a button or run a program, that guard steps in and asks, "Who are you? And are you really authorized to use this specific machine for this specific task right this second?" The guard doesn't care if you've been working in the factory all day long. They're going to check your ID and your permissions every single time. Okay, so this whole security guard concept sounds fantastic in theory, right? But how do we actually put that guard to work? Let's take a look at the technology that makes it all possible. The key technology that gives our security guard its power is something called micro-segmentation. It's a bit of a mouthful, but the idea is simple. If VLANs build big rooms, our trust zones, then microsegmentation builds a secure little fence around every single individual asset. We're creating tiny, isolated zones, sometimes for just one machine, which is what lets us enforce those super specific machine-by-machine rules. And the process itself is actually very logical. First, a user or maybe another device requests access to something. Second, the system verifies everything it can about that request, not just a username and password, but the health of their device, their physical location, all sorts of signals. Third, based on a really clear policy, it grants access to only the specific thing they asked for and absolutely nothing more. And finally, and this is critical, it logs and monitors all the traffic, because trust isn't permanent. It has to be constantly rechecked. Now, let's be real. The official guides on zero trust are great, but they often sound like they were written for a brand new modern IT setup. Trying to apply this to that old legacy equipment on the factory floor can be a massive headache. You can't just install a new security agent on a controller that's 20 years old. And this is where new, really lightweight tools are starting to pop up to bridge that gap. There are companies out there, like Trout, for example, that are building solutions designed to give you that secure, zero-trust connection to older systems, but without forcing you to do a full and, let's face it, incredibly expensive refit. And for anyone on a tight budget, that's a game changer. The cost of ripping and replacing that legacy gear, it's often a total non-starter. So these new tools offer a way forward that's both more secure and, frankly, a lot more realistic. Okay, so I know this might all sound like a huge, massive undertaking, but the great thing about zero trust is that you don't have to boil the ocean. You don't have to do it all at once. It's a journey, not just a switch you flip. So the big question is, where do you even begin? Well, the NIST guidance actually gives us a really practical roadmap. First things first, figure out what your most important assets are. What are the crown jewels of your factory? What's the one system that, if it went down, would be a total catastrophe? Second, you have to understand and map out exactly who and what needs to talk to it. Third, you write your security rules based on a simple idea called least privilege, which just means you give only the absolute minimum access required for a job, and not an inch more. And most importantly, number 4, start small. Pick one single critical application or area and protect that first. Prove that the concept works in your environment, and then you can expand from there. So, as we wrap this up, I'm just going to leave you with this one final thought. This isn't about trying to do everything at once. It's about taking that first, smart, focused step. So take a look at your own environment, your own factory floor, and ask yourself that question. What is the one critical asset you need to put a security guard in front of right now? Answering that is the real beginning of your zero trust journey. Thanks for joining me.